Hello, my name's Bob Willis and welcome to Winnie TV here at SMTconnect. We're talking to a whole range of different people about different subjects, and it's always a joy for me to understand different types of technology. And Dennis, would you just like to introduce yourself and also the fascinating product you've got in front of you?
Yeah, sure. Thanks for having me here. So I'm Dennis Marcon. I'm taking care of Innoscience Europe. I'm the general manager. And indeed, we are the largest manufacturer of GaN power technology. So it's the new generation of power devices after silicon. And they are step-by-step replacing silicon in many applications. The advantage of this technology is the fact that you can basically shrink the size of any power converter. You can make it much more efficient thanks to the intrinsic material property of gallium nitride. And this is what we do. And I think as Innoscience, we brought into this space by providing GaN in large volume and also the right price, because this was in the past a barrier for people to adopt this technology.
Just briefly, would you just like to explain to the watchers of the video?
Yeah.
You mentioned the term GaN.
Yes.
Would you like to just explain that a little bit?
Yeah, so gallium nitride, so GaN stands for gallium nitride, is a wide band gap technology. It has been studied for the last 20 years, let's say. I did my PhD on that back in 2005, so it took a little bit, let's say, for people to adapt it. And being a wide band gap technology means that it can hold high voltage with less amount of material. That's one of the property where this material has been studied. The other interesting property is that due to how you make this technology, without going into the details, it allows to have very high electromobility, and therefore you have much lower losses with respect to a silicon technology for a given amount of material. So the figure of merit is like 10 times better with respect to a silicon technology.
Well, just as a simple example, I'll pick up the old technology and
Yes.
you can show the newer
Right.
technology, and it's pretty obvious that the size reduction, and I was most interested that you highlighted the point which is the improved, or you just don't need to dissipate as much heat.
Correct.
So that's one of the major advantages of the technology.
That is correct, that is correct. So indeed, the fact that you have very high efficiency, it means that you don't need to dissipate as much as you have it with the traditional silicon. And that's why if you hold any, let's say, charger or solution made in silicon, often when you hold them, they are very, very hot. With GaN, you don't have as much problem as that. That's why you don't need such a complicated heat dissipation. And in many cases, you can get rid also of the heat sink in many applications. So, and that's the advantage that you get.
So you can also, I assume, look at different ways of protecting the circuit board as well, because obviously here you've got potting material, and this you would perhaps use a different technology?
Yeah, you encapsulate it in a different way. This is just, let's say, the demo board that we have, but I know that there are, for this LED driver solution, there are several customers that are commercializing this already in a much thinner form factor. And this is not just because it's cooler to have it thinner, but it's a real application that demands that. Like if you use this type of technology, you waste a lot of space, it's thick, it's not nice to see. This is much thinner, it gets integrated much better into the environment, into the design. So designers, they prefer this type of solution.
And where do you see the technology, where do you see other areas that the technology can be used in? Because you mentioned a couple of consumer manufacturers, but what other technologies do you see?
For sure, like also industrial, like motor drive. That is a huge revolution that is going on right now, motor drive. And they are consuming tons of energy, that a lot of that energy is wasted in heat. And by switching to GaN, you're not going to get also a better system, smaller, but it's also going to be much more efficient, and so in terms of thermal and also in terms of energy wasted.
So you highlighted some of the advantages, but what are some of the issues that a designer needs to consider? Is there anything?
I would say that you need to know, it's like when you're driving, let's say, a fast car, you need to know how to drive it. So let's say the designer, they need to know how to drive this device. And I see that in the past 5 to 7 years, there is a lot of knowledge on how to drive this device. You can have a discrete solution where you have a lot of flexibility and you know what you need to know what you're doing. However, we also introduce an integrated solution where the driver is inside the package. So basically, designer, they just take the gun with the driver inside. They don't have to worry how to drive the gun because that is already being taken care of by the integrated solution.
Oh, okay. So, in terms of applications, are there any limits to the technology?
Today, I would say with this technology, you cover application from data center, consumer, industrial. Today, the technology is rated at 700 volt, so you can use it for all the application that requires 700 volt, and there is tons of it. The next step will be to go toward 900 or 1200 volt, and that is, let's say, if you look at automotive, going toward 800 volt battery. And I would say GaN is not yet there, but there is a lot of going on to go toward that domain as well.
And obviously, you said you did your PhD?
Yes, I did my PhD on gallium nitride.
I can see that it's an interesting subject that you've obviously been involved with for quite a few years, and I can see how passionate you are about the subject.
Very good, thank you.
And it's great that you've come along with some practical examples to show, and that the size reduction is quite significant. So thank you very much.
My pleasure.
And wish you all the best for the show.
Thank you very much. Thanks for having me here.